What is kernel? A kernel is the core component of an operating system, using inter-process communication and system calls. It acts as a bridge between applications and the data processing performed at the hardware level. The kernel is responsible for process management for application execution, memory management, allocation, and input-output. Device management through the use of device drivers, system call control, which is essential for the execution of kernel services. There are three types of kernel that are monolithic kernels, microkernels, and hybrid kernels. Monolithic kernel is an operating system software framework that holds all privileges to access input-output devices, memory, hardware, interrupts, and the CPU stack. Monolithic kernels tend to be larger than other kernels because they deal with so many aspects of computer processing at the lowest level, and therefore have to incorporate code that interfaces with many devices, input-output, and interrupt channels, and other hardware operators. There are some advantages. Since there is less software involved, it is faster. As it is one single piece of software, it should be smaller, both in source and compiled forms. Less code generally means less bugs, which can translate to fewer security problems. There are some disadvantages that are making changes is not easy and testing takes more time. It is hard to maintain, patch, or extend. Bug fixing or adding new features requires the compilation of the whole source code, which is a time and resource consuming process. These are some examples of monolithic kernel. Microkernel is a piece of software or even code that contains the near minimum amount of functions and features required to implement an operating system. It provides the minimal number of mechanisms, just enough to run the most basic functions of a system in order to maximize the implementation flexibility. There are some advantages. Maintenance is generally easier. Patches can be tested in a separate instance, then swapped into the take over a production instance. Rapid development time. New software can be tested without having to reboot the kernel. There are some disadvantages. Larger running memory footprint. More software for interfacing is required. There is a potential for performance loss. Process management in general can be very complicated. These are some examples of microkernel. The hybrid kernel is a kernel architecture based on a combination of microkernel and monolithic kernel architecture used in a computer operating system. This kernel approach combines the speed and simpler design of monolithic kernel with the modularity and execution safety of microkernel. These are some examples of hybrid kernel.